Group 17 halogens. First question, the element which show both positive and negative oxidation state among the following. We know cesium alkali metal show only positive one oxidation state, no negative oxidation state. Neon non-reactive, so no oxidation states are known. Iodine, the halogen, it can show both positive and negative. So the answer is iodine. Fluorine we know show only negative one oxidation state, no positive oxidation states. Potassium again alkali metal show only positive one oxidation state. So the one which show both the positive and negative oxidation state is iodine. Second question, the correct order of bond dissociation enthalpy of the halogens. Here you have to note that bond dissociation enthalpy down the group actually decreases, but fluorine show an anomalous behavior, because for fluorine the bond dissociation enthalpy is much smaller than chlorine and bromine. So chlorine have highest bond dissociation enthalpy among halogen, then bromine, then only fluorine. The least bond dissociation enthalpy in I2. So this is the order of bond dissociation enthalpy. Correct order of negative electron gain enthalpy. Here also note the irregular observation shown by fluorine. Fluorine has down the group electron gain enthalpy becomes lesser and lesser negative, but for fluorine the electron gain enthalpy is smaller than that of chlorine. Chlorine has highest negative delta Hg value. Then only comes fluorine. When bromine is treated with the aqueous NaF, sodium chloride and sodium iodide separately, which is the correct answer. We know this is oxidizing action of bromine. We know the oxidizing power. The oxidizing power of halogens is in the order. Fluorine is stronger than chlorine, than bromine, than iodine. Bromine can oxidize only iodine. Bromine cannot oxidize fluorides and chlorides. So in the option no fluorine chlorine will be generated, only iodine will be generated. When chlorine treated with a sodium iodide, it would displace iodine gas. Only iodine is liberated. So option C is the correct answer. Only iodine is liberated. A higher oxidizing halogen can displace lower oxidizing halogen from the salt. So from sodium iodide, iodine is liberated by bromine. At room temperature, the reaction between water and fluorine produces. Fluorine is stronger oxidizing agent than water. So fluorine can oxidize oxygen from water. Water is oxidized to O2. So the answer is this one, O2 and F minus H plus, that is O2 and HF are the products. Question 6, the strongest acid. Here you have to remember acids are electron deficient species. Acids are electron deficient. And this electron deficiency depends on the oxidation state. Oxidation state of the central atom. Greater the oxidation state on the central atom, greater will be the electron deficiency and stronger will be the acid. So let us find the oxidation state of the central atom in each. Here we know oxygen minus 2, hydrogen plus 1. So the oxidation state of chlorine in HClO4 is plus 7. H2SO3, oxygen minus 2, hydrogen plus 1. So sulfur should here the sulfur atom 2 positive charge, 6 negative charge. So here the oxidation state on sulfur in H2SO3 is plus 4, sulfurous acid. In sulfuric acid, oxygen minus 2, hydrogen plus 1. The oxidation state shown by sulfur here is minus 8 charge plus 6. In HClO3, oxygen minus 2, hydrogen plus 1, so chlorine should show positive 5 oxidation state. So which is the strongest acid? The one containing highest oxidation state. Highest oxidation state is shown by chlorine in HClO4. So the answer is this one. HClO4 is the strongest acid perchloric acid. The correct order of acid strength. Again follow the same rule. We need to find the oxidation state of chlorine in all these acids. HClO, we know chlorine is in plus 1 oxidation state. HClO2, chlorine show plus 3 oxidation state. HClO3, chlorine is in plus 5. HClO4 plus 7. So which is the correct order of acid strength? That is the order of increasing oxidation state. Strongest one HClO4. Stronger than HClO3, then HClO2, least acidic one HClO. So the order of oxidation state, as the oxidation state increases, acid strength also increases. So that you have to note, acid strength directly related to oxidation state of the central atom. The correct order of acid strength. Here HOCl, HOBr, HOI. Here we cannot compare the oxidation state because in all the three the halogen atom is in plus 1 oxidation state. But when we compare the nature of chlorine, bromine, iodine, down the group we know the non-metallic character. Non-metallic character down the group from chlorine to iodine decreases because metallic character down the group increases. Non-metallic character down the group decreases. So the non-metallic character, as the non-metallic character decreases, acidic strength also decreases. That means HOCl is stronger acid than HOBr, than HOI. Question number 9. The products obtained when chlorine gas treated with a cold dilute NaOH. So you should know the reaction of chlorine when chlorine react with a cold dilute NaOH. The products are sodium chloride and sodium hypochlorite. Sodium hypochlorite, OCl. This is hypochlorite. Chlorite plus H2O. This is the reaction. So the products are chloride and ClO minus, hypochlorite ion. So the answer is option A. Chloride and Cl hypochlorite ion are the products. When chlorine react with a hot concentrated NaOH, oxidation number of chlorine changes from. So for this one also we need to know, you need to write the chemical equation, that is when chlorine react with a hot concentrated NaOH. NaOH hot and concentrated. Here the first product is the same, sodium chloride, as in the case of dilute cold NaOH. But the second product is different, that is, so instead of sodium hypochlorite, here sodium chlorate will be produced, NaClO3 plus H2O. This is sodium chlorate. ClO3 minus is the product. So here it is asked in the question, the oxidation number of chlorine changes from. So in Cl2 the oxidation number of chlorine is 0. Oxidation number of chlorine in Cl2 is 0. In sodium chloride the oxidation number is -1. In sodium chlorate the oxidation number of chlorine is oxygen -2, sodium +1. So the oxidation number of chlorine should be +5. So the answer is the oxidation number of chlorine changes from 0 to -1 and 0 to +5. So the answer is option B. Option B, that is 0, oxidation number of chlorine changes from 0 to -1 0 to +5 is the correct answer.